The James Webb Space Telescope, JWST, has sparked an intellectual earthquake in the world of cosmology, raising questions that could fundamentally shake the foundations of how we understand the universe. For decades, the Big Bang theory has been the bedrock of modern cosmology, a model that suggests the universe began with a cataclysmic event roughly 13.8 billion years ago. This explosion, the origin of both space and time, set into motion the creation of everything we know: galaxies, stars, planets, and, eventually, life itself. The theory has been supported by overwhelming evidence: cosmic microwave background radiation, the redshift of distant galaxies, and the distribution of matter across the universe. But now, a series of groundbreaking observations from the JWST are forcing scientists to reconsider whether the universe is truly as we've always imagined. The telescope has detected galaxies that seem to exist far earlier than the Big Bang itself. Yes, you read that right, galaxies that appear to be older than the supposed beginning of the universe. The implications of this discovery are staggering. If these observations are correct, they suggest that our current understanding of cosmic history is fundamentally flawed at best, and possibly even completely wrong. These galaxies, remarkably massive and well-formed for their apparent age, pose a profound mystery that challenges everything we thought we knew about the evolution of the cosmos. JWST was designed with one bold mission in mind: to peer deeper into the universe than ever before. By capturing infrared light, it can penetrate the clouds of gas and dust that usually obscure our view, revealing galaxies and cosmic structures that were previously hidden from us. This gives the telescope the unique ability to observe light from the very distant past. When we look at a galaxy billions of light years away, we are, in essence, looking back in time, seeing that galaxy as it was when its light first left, often billions of years ago. This provides an invaluable window into the early universe, offering a glimpse into the formation of the first stars, galaxies, and even black holes. But what JWST has uncovered is far more perplexing than anyone could have predicted. Among its first discoveries, JWST found galaxies that appear to have formed just a few 100 million years after the Big Bang. These galaxies are not just faint, irregular patches of light as expected, they are large, bright, and surprisingly well structured. According to the standard cosmological timeline, it shouldn't have been possible for galaxies to form so quickly. The early universe, only a few 100 million years after the Big Bang, was supposed to be a chaotic, hot mess, a time when stars were still forming in primordial gas clouds and the universe was slowly beginning to cool. The idea that galaxies could have reached such a level of sophistication and size so early has left cosmologists scratching their heads. But it gets even more mind-boggling. As JWST continued its observations, scientists discovered galaxies with redshifts so extreme that they appear to predate the Big Bang itself. Redshift, a shift in the wavelength of light caused by the expansion of the universe, is used to measure how far away a galaxy is, and by extension, how old it is. The higher the redshift, the further away and older the galaxy is. These newly discovered galaxies seem to have redshifts that indicate they are older than 13.8 billion years, which means they existed before the Big Bang, defying the very concept of time and space as we understand it. The implications of these findings are profound, and they challenge the most fundamental assumptions of cosmology. If these galaxies really existed before the Big Bang, it would mean that our entire understanding of the universe's origins is fundamentally flawed. Could it be that the Big Bang wasn't the true beginning of the universe, but rather a transition from a previous state, a cosmic rebirth? Could the universe be part of a cycle, expanding and contracting in an endless loop? Or could we be dealing with something even stranger? Perhaps the universe we see is just one of many, part of a multiverse where each universe has its own timeline and set of physical laws. To explain these strange galaxies, scientists are exploring some radical ideas. One possibility is that the universe undergoes cycles of birth, expansion, contraction, and rebirth, with each Big Bang marking the transition from one phase to another. In this model, the galaxies seen by JWST could be remnants of a previous universe, somehow surviving the transition from one cosmic cycle to the next. This idea is not new, it has been proposed in various forms by cosmologists and physicists, but now it seems more plausible than ever. Alternatively, the galaxies observed by JWST could belong to a neighboring universe within a multiverse, their light somehow leaking into our own through a process known as quantum tunneling or even a wormhole-like phenomenon. Such a concept, while speculative, is grounded in serious scientific theory. If the universe is part of a larger multiverse, each universe could have its own set of physical laws, dimensions, and timelines, allowing for the existence of galaxies from another realm spilling over into our own. Another possibility is that the standard model of cosmic expansion is incomplete. The theory assumes that the universe has been expanding uniformly since the Big Bang, but what if this isn't true? Could there be regions of the universe where the laws of physics behave in radically different ways, allowing for anomalies like galaxies that seem to predate the Big Bang? Could time itself be more complex than we realize? If time is not linear but cyclical or multidimensional, perhaps it's possible for structures like galaxies to appear to defy the flow of time and exist outside the boundaries of a singular Big Bang event. These theories challenge our basic understanding of the universe and require a re-evaluation of the very laws of physics. Some theoretical physicists, including Michio Kaku, have suggested that these findings represent a major turning point in our understanding of the cosmos. Kaku emphasizes that the universe is often stranger and more complicated than we can imagine, and that we must remain open to rethinking the very nature of reality. He also points to alternative theories, such as string theory and quantum gravity, which offer explanations for these anomalies, models that suggest the universe is far more complex than our current models can account for, operating on multiple levels, with dimensions and forces that are hidden from our perception. As fascinating as these possibilities are, they raise even more questions. How can we prove that these galaxies truly predate the Big Bang? What kind of evidence would be required to upend a theory as well established as the Big Bang? And how do we reconcile the fact that the galaxies observed by JWST are not just faint, irregular blobs of light but are instead large, bright, and well-formed? These galaxies show evidence of complex chemical compositions and structures, spiral arms, bulges, and disks, that seem far too mature for their age. They suggest multiple generations of stars have already lived and died, something that shouldn't have been possible in the early, hot, chaotic universe. The idea that the universe is part of an endless cycle, with each Big Bang marking the beginning of a new phase, has significant implications not just for cosmology, but for our understanding of existence itself. If the universe doesn't have a singular beginning but instead undergoes an eternal loop, what does that mean for us? Are we simply observers in this endless cosmic cycle, or do we have a role to play in a much greater reality? These questions are not just theoretical, they touch on the very nature of life, consciousness, and our place in the cosmos. As JWST continues its mission, more discoveries are sure to follow, and each new revelation will bring us closer to understanding the true nature of the universe, while also raising more questions that push the boundaries of what we thought was possible. Could the universe be stranger, more complex, and more beautiful than we ever imagined? The search for answers is just beginning, and it will continue to inspire and challenge us as we embark on this extraordinary journey to uncover the mysteries of existence itself. Whether these strange galaxies are remnants of a previous cosmic cycle, projections from another universe, or something we haven't even begun to comprehend, they remind us that the universe is full of wonders waiting to be uncovered. And as we continue to probe deeper, we may just find that the answers we seek are far more